Okay, so better results from AI-augmented programming. This is based on a bunch of experimentation I've been doing with Cursor. I have an example app that I'm going to show, and I'm going to take the risk of doing a live demo. In the end, it's either going to be a live demo of all the things that go badly with AI-augmented programming, or then it's gonna go nicely. I don't know which one it's going to be, but it'll probably be instructive in either case. I'm going to wing it, so let's see how it goes.
I guess it's prompter error if it goes bad, right?
Yes, it is of course the prompter's fault. The machine is always correct, so if you don't get the right results, then it's all you. So with that, let's get started with the presentation first. And first thing is that a bit of terminology. So what I'm presenting is not vibe coding. So I'm calling it AI augmented programming here. Vibe coding is defined as you kind of forget that the code exists, but this is not that. So just because that term keeps popping up, so I thought I would mention that. So the first thing is read the code and understand it. So I haven't always read the code. While experimenting, I've just I just let it generate, because if you let it generate code, it will generate so much code you don't really have time to read it. But it's generally a good idea to read the code if it's for something that you want to develop long term. I have gone back and read the code that I didn't previously read, and yes, it's not always pretty. Sometimes it's nice, but it's not always. And then it's probably better just to do it right the first time rather than then going back and refactor it. Maybe the agents will get better at some point, but they're not there yet. So the first topic is rules for AI. You can see there on the right side the 3 laws of robotics. So a similar thing. A robot may not injure a human being or through inaction allow a human being to come to harm, and so on. These are from Isaac Asimov. So we are doing a similar thing here, except I guess in this case we are setting rules that you're not supposed to do harm to the code. The agents, they don't yet have the capability to hurt humans, except maybe mentally, but well, that's another topic. So what are the rules for, and what are some good rules to have, and what's a good way of thinking about the rules for the AI? So rules are, a lot of these systems have, like you have .cursor/rules. Like you have a bunch of basically markdown files in your repository, and you store rules that are basically should always be followed by the agent, although it doesn't necessarily do that. But then you can add additional strengthening words to make it follow it a bit more strictly. So the way you build these rules is that the agent does something silly. If you don't have any rules, then it's bound to do something silly quite often. But when it does something silly, then you create a rule to fix it. And then you work until it does something silly again, and then you create another rule, and so on until it does fewer silly things, basically. So you get this ever better agent. And some of these things are like, it is always silly to do this, and some of them are just workflow preferences, but those are all stored as rules basically. So I just to give an idea of what sort of rules you might have. Some examples of rules that I've created based on experiences with Cursor is deny git commits. So when I first started out with Cursor, the agent wanted to commit all the time, which is like you're supposed to commit early and commit often. That's nice, but then it's also nice if you have working code. If you have something that actually runs and that has some kind of tests, but then it would just generate the code, mark it as done in the planning file, and then just commit it. And that's not very nice. So I created a rule to deny git commits, and I'm using Git as an additional layer of safety there, in addition to what Cursor provides, which is previewing the code in a nice view. And another thing, you of course want to quite often run some shell commands for running tests or linting or whatnot. And one of the things that the agent was doing was constantly running commands in the wrong directory. So I created a rule where it would prefix all commands with a cd command to go to git root and then run all commands, so that it would like basically start from the git root and build a path from there and then run the command. And after that, it has always run, or well, 99% of the time it runs commands in the right directory. Well, which saves time, because then it doesn't, like, every time it runs a command, it doesn't need to first, oh, looks like I'm in the wrong directory, I will switch, which is annoying. And then another one that's I've noticed it's also something that's quite commonly used with these rules is to use test-driven development. So you have a rule for test-driven development. The agent is like, if you ask it to implement something, it by default it's not going to write any tests ever. So you basically have to add a rule for writing tests, or then you have to manually every time ask it to write tests. So you might as well create a rule for test-driven development. So to make this a bit more concrete, I have some screenshots from Cursor, like what do these rules look like. So in my project, there's .cursor/rules. There's this no git commits rule. There's the rules don't have a specific strict syntax or anything like that. But you can add like type strict prohibition, and then that's going to make it a bit more likely that it will actually follow the rule. And like a strong language, like not allowed to commit any code to Git under any circumstances, and so on. Unscientific, that seems to help. This is actually like this, like it actually follows this rule. Like it hasn't actually done any commits after this
here, one. Apparently, at least for some models, death threats do help if it's really following the rules, which is funny.
And swearing.
Yeah.
But like I'm kind of like hedging my bets when Skynet takes over the world. I don't want to like I don't want to upset the agents too much at this point. So I'm
Yeah, the dictator doesn't care if you lick his boot.
Yeah. But like it's it would be nice if you didn't have to think about these sorts of things, but like at least at this point, this is the state of prompt engineering today. I think like when the agents develop a bit more, then I think we might get over this phase.
Yeah, and actually it's more green approach to not to use please because there are extra words and they use extra processing. So just be blunt at the moment.
Yeah. So also thinking of it from a FinOps perspective at the same time, that's also good. Another, this is the ensure correct directory for shell commands. So again, strong language, strict rule, the AI assistant must ensure it is the correct directory before executing any shell commands, etc., etc. And so you basically do cd target directory absolute path, and then you use git rev parse show top level to determine the git root, and then you go from there, which helps a lot. Like this has been a big time saver.
You're using a thought line here on only absolute paths must be used / never relative paths. Does it really understand those? Ajatusviiva suomeksi. In Finnish.
I don't know if it makes a difference. I think it would understand. No one really understands the like deeper logic behind how the agents work. So
yeah, but seems to work.
Yeah.
Okay.
This is also like sometimes you do need to experiment a bit with this. And I think this is also like when context windows become bigger, then this is less of a problem, because then there will be less of a need to drop things from the context, and you can add more rules, and then it's going to be like what these tools are also doing is it's dropping stuff out of the context that they don't consider to be necessary. So then with larger context windows, these problems, when the agents or the models develop, then that's going to also help things along. And one final point about rules is that before we move to the next topic, is that you can quite easily have the AI generate the rules for you. So you write a short prompt, and then it's going to generate a rule with examples of bad behavior and examples of good behavior. So you don't have to write the rules yourself. So that's also handy. But at least in Cursor, it's not allowed to modify its own rules. So you have to write them elsewhere and then manually copy them in place. I think it's like I think that's also like seems like a good safety feature in AI systems, that they are not allowed to modify their own rules. That's the sort of what could go wrong thing if you let them rewrite their laws of robotics.
Yeah, that's a good safeguard for those.
Yeah. So next up, this is another important one. So context in Markdown stored in Git. So when you ask the agent to do something, by default, like it doesn't remember anything. It's always a fresh start, and this is both a good thing and a bad thing. So you need to somehow give the agent memory, because otherwise it's going to be like if you take an existing project and you don't give it any context and you give it a prompt, then it might think that your Node.js project is actually written in Python, and it's going to start generating Python code. So it needs some basic facts about the project. And you can also use this as documentation for humans at the same time. So it basically documents basic facts about the project. I'll show some examples of what this looks like, and one example implementation of how this can be done in a systematic way. So what I'm using at the moment is Klein Memory Bank. This is originally for Klein, which is a VS Code plugin, but it's based on rules, so it works in any agentic coding tool that has a rules system like Cursor. So the Klein Memory Bank is a structured way to store project context, and it's like a memory for the agent that is persistent, and you can pick and choose what you store in that memory. So you can also drop stuff out of the agent's memory if you don't think that it should remember that thing because it's not helpful. And it consists of a bunch of files. So it starts with a project brief, which has basic details about the project, not going into a lot of detail. You can write this project brief file yourself as a kind of seed for the project, and then you can generate the other files from the project brief based on the client memory bank rule. You write the project brief, then you initialize the memory bank. Like you type in initialize memory bank when you have the client memory bank rule in use, and then it will create the other files. I have links at the end for this if you want to read about it in more detail. So the basic workflow with the memory bank is that you start your coding session. The first thing is that the agent doesn't know anything. So then you read the memory bank files. You can reference the memory bank in Cursor. You could do @memory bank. I'll show that in the demo. It will go and read the memory bank, rebuild its context, and then it will know stuff about the project, and then it can actually do work. And then once it's done, then you ask it to update the memory bank, and then the session ends. So when you've implemented something new, you update your status in the memory bank, and then your memory is once again updated.
Can you rewind one slide?
Yes.
Looking at this flow chart, wouldn't it be nice if you had such a memory bank of the project you are supposed to be working on at work?
Yeah. But this is kind of like it's also automatically building this kind of context for you. So it's perfectly human readable as well. So it's kind of self-documenting at the same time, which is handy. So then you can make sure that like you update the status and the progress of the project as it goes along. One limitation with this I don't know what's going to happen when you have a really long-lived project and you start to have a huge memory bank. Like how do you pick and choose what you actually put there with the context windows? I have a small project. It doesn't yet hit this problem, but if you have a huge project, the memory bank would also be huge. So then you might start hitting issues where the memory bank becomes too big. That's something to solve at some point. And there are some other solutions for this, like Taskmaster. It has a slightly different approach, but I think those are something that I haven't yet figured out with my workflow. So here's an example of the project brief for this Ecostate project that I'm going to be showing in the demo as well. So it's just a brief text description of what the application is about, a web application that provides interactive map-based visualizations and correlations between property prices and environmental quality indicators in Finland. And then it has some core requirements. It has some other stuff like it's probably less than one A4 page of text. And you can see here, there's this memory bank directory, and there's a project brief, there's progress, product context, active context, system patterns, text context. And those all come from the client memory bank rule. And then in tech context, you remind the agent that you are not creating a Python project. You are, in fact, using React and Node.js. And this is like a funny thing about these agents is that one anecdote that I read is that quite often they are somehow obsessed with Tailwind CSS. So, something about them like makes them assume that projects use Tailwind CSS. So this is like the styling here. This is actually a hallucination. I don't use Tailwind. Note, verify if actually used or if standard CSS component specific CSS is the primary method. So somewhere they get that, yes, everyone's using Tailwind CSS, and I like, that's weird. I should fix that. But you are not immune from hallucinations in these documents either. And progress is it has a checklist of things that are already implemented. So in this case, the CI/CD pipeline implementation is in progress. So it marks things that are done and that are still to be done. So it doesn't start implementing things that are already implemented, because that's also a pretty common failure case for the agent. So it's really good to have this kind of a checklist of what's already been done. Next up, tight feedback loops for the agent. So the agent is like, they're fairly confident in their work. They like to generate code, and they don't really, as I said, they don't really write tests by default. So I think it's really useful to create these tight feedback loops through rules and other means that they actually verify that the changes they make are correct before doing anything with them.
So I actually would give out to VS Code. The integrate, like the loops there, the feedback loop is very tight in VS Code when using AI agents. So just a note there, I've been using both a lot, and VS Code is very adamant about checking with you, the user, about what you're doing.
Yeah, like Cursor is the same. It shows all the code, and then you can, like, line by line, you can clearly see what's changed, and then you can approve it. But then like test writing is something where I've noticed it might be different in VS Code if it has some kind of like or Copilot, if it has like some kind of additional system rules that are emphasizing the importance of writing tests. But at least with Cursor, I've noticed that it doesn't write, or the agents used, or the LLMs used by Cursor, or the way Cursor uses the LLMs, or whatever the right terminology is, it doesn't really write tests. So then you can, I've had a TDD rule, and I explicitly asked it to write tests in different cases. And another good thing to have is also to set up a linter rule for code complexity, because the agents can be prone to overly complex code. So you can set up checks for whether functions are overly complex, so that you don't end up creating a lot of spaghetti code that's difficult to read. And stop the agent when it gets into a bad loop. So what does a bad loop mean? Let's say the agent generates some bad non-functional code, and then you say that it doesn't work. It starts fixing it. It has no idea how to fix the code. It's going to come up with some crazy idea of what's wrong, and then it's going to start implementing that, or it's going to start deleting code, and it doesn't realize that it can't just restore the code. It's going to start doing all sorts of destructive things to the code, and it's just going to go into this degrading loop of ever worsening results when it can't figure things out. So usually the best thing is to do is just stop it right away, throw away the code, and take a different prompting approach. So quickly throw away bad code. So it's really easy to generate more code. Like, you don't lose much. Like, even if it generated like 500 lines of code, you don't lose much by throwing it away if it took like 2 minutes to generate it.
And my top one favorite bad loop generator is that if you have a case where the code and the tests are both wrong, it will immediately after fixing the other figure out that, hey, the other one must be correct, which is not. And then there you go.
Yeah. Another thing happened. I was complaining that, hey, you didn't follow the TDD rule. Like it created the implementation, and then it wrote a test for the implementation that it just created after I pointed out that it didn't follow TDD. And then it got confused because the test actually passed because it had just written the implementation. And then it started doing something silly. Like, well, this wasn't supposed to pass. What is wrong? Like it doesn't really understand. Like it kind of forgot that it implemented something, and then like it doesn't. It has a bit of problem with short-term memory sometimes. So just do a rollback. Cursor at least provides a really nice features for just rolling back to a previous state. It will just make it as if you never ran the prompt. Then you can look for more information with just the traditional search, so you can write a better prompt. And then one thing that's also useful is to change to a different model. So if you've been using Gemini, you can switch to Claude or vice versa. And then the different models have slightly different weaknesses, so quite often that also helps. Like that particular problem with that particular prompt wasn't solvable by Claude, but Gemini is able to do it immediately. So like there's no need to get attached to the code. It's almost free. You can generate loads and loads of code, and just even like you can even be picky, like, okay, that's almost correct, but like I don't quite like it. It's almost fine, but I'll just throw it away and generate it again with a slightly different prompt.
Or the same prompt.
Yeah, because they're not exactly deterministic, so you might actually get different results with the same prompt as well.
And you'll only burn a little bit more of the rainforest.
Yeah, but like it's worth it for better code, like slightly better code, because we want elegant code rather than rainforests.
Yeah, you could type the one line yourself, but
A couple of anacondas here and there.
Yeah. So then injecting up-to-date documentation into context. One anecdote I noticed is the agent wanted to use a really old Node version by default. And one of the things that it also does is that when you need new libraries, you need new packages, it's just going to edit package.json, for example, manually, and it's going to add the version that it thinks is the latest one, but it has no clue. Because there's a cutoff date for the LLMs, and they don't know anything after some date in 2024, let's say. So you can.
I think this is a real problem, not just in coding, but by AI's fetching old documentation in general.
Yeah, like that also goes with customer service agents and other things as well. So it's not unique to coding, but there are some coding specific solutions, which I'm going to talk about next. And in addition to this, one of the things I've done is I've set up a cursor rule for when you need to add new libraries, don't add them directly to package.json. Instead, run npm install. And then that also helps a lot. So there is an MCP server called context7. You can configure that through mcp.json in Cursor. And then you can fetch up-to-date documentation in a format that is nicely formatted for LLMs just by prompting use context7. So if you're adding some new functionality, some new libraries, then you add use context7, and then it's gonna fetch documentation for those libraries. It's going to figure out what the latest version is and so on. So it's going to give better results for newer stuff. And it's not just for getting the latest stuff, but it's also for fetching documentation on how to use specific tools. And it has a documentation for a bunch of different tools. So it's quite handy. There's also a built-in documentation feature in Cursor. You can add different documentation, which is useful for things that you wouldn't have, let's say, in Context 7. Like I've added documentation on things that are not as common, like documentation for the geoinformatics APIs from HSY, or like how to query the Statistics Finland API, that sort of thing.
Have you tried with a PDF file document for some API?
I tried it. I'm not sure if it worked quite correctly. There was for Statistics Finland, there was one for the PX Web API that they use, but I don't remember if the PDF version worked nicely. I did try it.
Yeah, how specific do you need to be when prompting for documentation on your own design? Like, is it usually a quick start guide? Can you make an in-depth manual or something between? Or
I suppose it depends on if the documentation has needed information, and quite often it will also automatically figure out when it needs to do a web search. So it will also like automatically search the web for newer stuff.
Yeah, I was thinking of writing for your own documentation, as in comments in code or README and MD, or
comments in code. It does a bit too much, even, and it updates them even if the code didn't change between. Okay. So there it's a bit too anxious in or too excited in writing comments. Right. And README files and such things, it will sometimes figure on its own that I should write this. And the sort of basic user guide for a command line interface, it does pretty nicely, but then it might get out of sync that maybe the command that it previously documented doesn't exist anymore, doesn't work, or something like that. Right. But if you read the entire code base, update the documentation, it usually does an okay job.
Good.
Yeah. Then balancing speed and quality. So I mentioned that this is not about vibe coding. I think vibe coding has its use cases, like you can quickly generate POCs or try things out. You can do what you can do in an existing project is to create a branch and then just generate whatever crap to experiment with things and then throw it away. And that can be quite useful for discovery and figuring out, like thinking about the problem and figuring out what's possible and coming up with ideas. But then you just need to remember to throw that stuff away. So then the advice from the presentation is more for the trying to also maintain the quality. And I think at the same time, like if you just use like something like tab autocomplete, you're just using fancy autocomplete. You're not using AI much, or maybe you're just using ChatGPT and asking for some code snippets. Then that's significantly slower than like using the tools to their full potential as well. So that's not great either. So it's kind of a balance of finding just the right speed where you still get good quality code, or the quality of code that is good for that context, basically. And of course, like it really depends on the use case. And even if AI is generating the code, the usual best practices still apply. So TDD, separation of concerns, modularity, cohesion, stability. So those things are also going to make the code easier to edit for the AI. It's not just easier to maintain for humans. So spaghetti code is going to be difficult for everyone, agents and humans alike. Okay, so example app. I'm going to try to show a demo. Let's see how it goes. It might go horribly wrong. Then I will claim that it's an instructive case of how not to do things. I'll wing it. So let's see how it works. First, some introduction about what I'm showing. So the app that I've been working on to experiment with these tools is called Ecostate. It's a full stack web app for visualizing property prices. So it at the moment it visualizes property prices in the Helsinki capital region. It's almost entirely AI generated code. I have touched the code myself very little, and that's been on purpose. I've tried to see like what the results I get if I just let it generate. Node.js and React, Leaflet and OpenStreetMap for maps. There's a bunch of public APIs. It downloads or like it fetches property price data from Statistics Finland. It fetches postcode boundaries from HSY. There's plans also to add some other APIs for additional visualizations. I haven't gotten around to that yet. So far, it's pretty basic. There's Terraform for infrastructure as code. That's also almost entirely AI generated. And it's hosted in Azure. There's a link. If you follow it now, then you will be distracted from the presentation. So please do that later. And for the demo, the use case that I have is, I'll first explain the problem. So the HSY API has postal code boundaries in the EPSG3879 coordinate reference system. I had to look up that I'm like expressing this correctly here. Like it is a coordinate system that is specific to Finland. And it is, of course, a different coordinate system than the one used with GPS or that's used with OpenStreetMap and Leaflet, which is EPSG4326, which uses WGS84 as its datum, I think. I'm not a geoinformatics specialist, but like they are different coordinate systems. You need to do a transformation somewhere, or you can't visualize the postal code boundaries. So in the AI-generated code, it's just calculating the conversion over and over again. Like it like when you render again, it's just going to calculate this conversion. So in the demo, I will try to optimize this. This is actually a finding from the AI, so I asked it to review the code, and then it created a checklist of things to fix to optimize the front-end performance. And this is one of the things. I want to point out that it would make a lot more sense to just do this in the backend instead of the front end in the first place. But for the demo, we are making some small changes to the front end, and hopefully they work. Things might also go horribly wrong, but let's see which one it is. I opened a new chat, so now this is fresh. All I have is my markdown files and the memory bank. So for this transform coordinates optimization here, I have as a first step identify where transform coordinates is called, analyze postcode boundaries.tsx component to find all call sites of the transform coordinates function. And then determine if the function is called within the render path or inside use effects hooks.
Did you prompt this file into existence?
Yes.
Yeah, okay. So it's running in loops.
Yes. And then it's gonna use memo, and then it's gonna do memoization for the results, and then that's gonna hopefully make it slightly better. So let's do at memory bank. So I'm asking it to add the memory bank to its context, and it has a specific rule to read the memory bank in a specific way. So it's going to check the project context and so on. And then I have this front-end performance improvements.md file, which I have open here. That's also in the context. And then I'm going to add this postcode boundaries file in the context like that. And then I'm going to write the prompt. So proceed the work plan for optimizing transform coordinates performance in postcode boundaries.tsx. Start with the first step outlined under work plan. And then it should read the memory bank, and then it should hopefully not break the UI. And this is a nice demo in the sense that if it breaks the transform coordinates in some way, then that should be glaring and immediately obvious, because all the postcode boundaries are going to disappear. And here it's using Gemini 2.5 Pro, which I found to be actually more effective than Claude in my work. Claude 4 I haven't tested that much, but Gemini seems to be working quite well for most things. So let's see how that goes, or if it breaks horribly. Analyzing optimization strategies, okay.
The language it uses is always so pompous and sort of ultra professional.
Yeah.
Romantic.
Confirming initial strategy.
Yes.
Almost as if these large language models would know something about language.
Yes.
They don't know. They just have a model for it.
They just keep on guessing.
Yeah. Have you tried if you can adjust the way it speaks through rules?
Verbosity.
I don't know of verbosity, but it could be like a more common speech.
Yeah, or Super Mario. Hey, it's me. I got to write this code.
Yeah. I think in this case this is actually like its internal thinking still. Like it shows up in gray, so it's not yet actually showing the answer. So it's
is sort of new to this, that it's thinking more out loud than it used to.
Yes.
So it's not a black box anymore.
Ooh.
Oh, nice. We're having trouble connected to the model provider. Okay, let's try it again. It seems to have thought about this for quite a long time. This might serve as a nice demo of the bad loop behavior now. We might need to switch to Claude.
Can you define like the trying times, or I don't know how to express like a fail fast after these, or just keep on trying until you get it right?
I don't think so. I think like it's in thinking mode.
Yeah.
So
this seems and it seems to be so that it doesn't really want to stop soon with anything.
Yeah.
I have a constant problem is that it's trying to do a bit too much.
Yeah.
And sort of a bit too much is the best it can do.
Yeah.
But it naturally it will sort of finish the project.
Well, it tries too hard.
Yeah.
I think just like a junior developer.
I think it might be time to switch over to Claude at this point, because it just seems to be kind of stuck into like, oh, now it's doing something. thought for 81 seconds.
Mhm.
Okay, so that's not too bad. Maybe I was just being impatient. And
This is teaching our bosses that thinking for 1 second is a long time and should be avoided.
Yes. Okay, so now it's updating the plan here. Reflecting completion.
Can you, you probably can't, but can you make the prompt like I'm moving to the step next, like please go with Y, or so it would have a pause function, so you could.
Yeah, you can ask it to like more specific, like I want to do this and that step.
Okay.
Yeah, and it sort of don't proceed without confirmation. And one thing which for if you need something like a GUI thing, what I found almost impossible to do with by prompting is that if you want a sort of make a test where I answer you. So practically that show me in the GUI and I'll say yes or no if it's good.
Okay.
It won't comply to that for a long time. But if you sort of manage to integrate that into testing, you might have a loop where you say that this got worse or better.
No, that would be good. Compare.
Yeah, but that's yeah. I guess you'd need a specific tool to sort of not part of the project to integrate.
Yeah. Oh, hey, it finished. It actually like it looks like it actually went ahead and did more than I thought it would. Seems to
All the
have
steps.
yes, all the steps.
Please do all the needful.
Yeah. So what did like? Let's see if the results are any good. Like, what did it actually change? So here we have. Where do we have that? Like, we have some stuff for the coordinate transform. Okay. So we have transform coordinates here. It got rid of the JSON parse JSON stringify GeoJSON, which was marked as a problem for each feature. Like it's gonna do that transformation and returns GeoJSON. Okay. What else did change? Oh, I can actually, you can jump between the snippets here. That's it. Yeah, I'm
straight into production without testing.
Yeah. I mean the app here, the live app here on the left is still working. So I'm a bit maybe was this whole stringified GeoJSON, like what was the
Maybe you need to reload the app.
Yeah, I'm just kind of wondering, I we just dropped that whole thing. Like, why were we doing it in the first place is the thing I'm wondering. Like, if it, okay. Yeah, I mean, you shouldn't have to reload, and it should be working now. So we can, of course, you can't tell if it's faster. And like a vast majority of the delay is coming from actually like the API calls. And so, yeah, a bit of a, and in any case, it would be better to do the transformation and then cache the results in the backend. But yeah, it didn't break it. I think the solution it ended up with was suspiciously simple. I think what I would do is I would have to read this thing through with thought and see like why did it change it in this way. like, was this like this stringify thing just a complete waste of time in the like original?
Can you also make it to provide a change log? What actually changed?
Well, you can. Yes. Well, this is the whole change. Like you can see the diff is here. This is everything that it changed.
Okay.
But the memory bank is, at least for me, it writes it pretty much like a change log. So it has the previous steps and it has the next steps, and
Yes.
so
Right.
yeah. So it does. Yeah, it seems that those things that it updates its status are pretty good. So if your teammates would be updating so much and you'd be reading them, work would be more fun in general.
Okay. So it's kind of its own state file.
Yeah, in the way that it reads and writes documentation, it's actually better than humans. That's one of the good parts.
Yeah. So you kind of get documentation
actually
as a
does it.
side effect. Yeah.
Yeah. And that's definitely, even if you're my personal take is that I mostly want to use it as a sort of autocomplete mostly, but the good part is that when I'm done with something, it's like read the code, update the documentation, and that part is the sort of improvement, because turning specific code into human language is the sort of tedious bit, which is that it's doing good. The prompting, which is the reverse, that's harder. That's the impossible problem.
That's all I have for today. I have one last slide after this one, which has links. So you can check the GitHub repository for the project. This has, like, you can read through the rules that are there and the memory bank and what sort of stuff it has. A standard disclaimer may contain small amounts of hallucinations. So, like, this is an experimental project. I haven't really been super nitpicky about the code quality at all times. So like the test quality might be bad, and like you might have weird references to Tailwind CSS, but you can check out the repo for what the rules and the plan files and so on. And there's also links to the client memory bank context 7 and then the cursor rules documentation. That's all. Any questions or final thoughts?
I would like to add that point that we discussed in the DevOps book club, is that if you write your tests with AI, you shouldn't have them as an afterthought, because in a lot of customer cases, what we've started or what I've noticed at least is that the code is when you ask AI to write a code, people actually look at it and see it, and then they ask AI okay, this code now works in my brain, and then they ask AI write the test for this thing, and they're yeah, whatever comes out of this, this gets slapped on it, and the test coverage increases, and that's it. And then you actually look at the test, and it's if this function returns something, okay, it returns 5 errors, but according to your test, that's fine.
There's a reason why it's a TDD, test driven.
Yeah.
Nice after.
But there's really, if you want to write code, especially for the sort of integration thing that you'll pretty much know that it transformed it from A to B correctly. Then writing the behavior driven type of testing, and I don't mean cucumber, but testing the behaviors and writing those yourself and then not care for the code is a better strategy. So that the test actually comes first, and it might be the only thing you write, but at least, yeah. Just one way that works for me.
Yeah, I would guess that TDD would also help here, and BDD would help with that with the test quality as well. So if you actually like take the time to write the tests and then actually take the time to read them and then do the implementation based on those, then I think that would definitely help with that as well.
Good stuff. Thank you.
Thank you.
Thanks.
Thank you.
Thank you.
Thank you.
I will stop the recording.
Are we?